Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you're here with us. We've got a great topic. Our topic is continuous integration to shift left testing across the enterprise stack. My name is Mitch Ashley. I'm Managing Analyst with Accelerated Strategies Group, and I'll serve as your host and moderator for the webinar. A few housekeeping items. We are recording the webinar, and we will send an email to all participants with links to both the recording of the webinar and the slides that are used. We're also giving away 3 $50 gift cards, so please stick around to the end, find out if you're one of the 3 lucky winners. We encourage questions. Our speakers are fantastic, very knowledgeable on the topic, and love questions. So please enter those into the GoToWebinar control panel, the questions panel, please. Now let's move on to our topic, continuous integration to shift left testing across the enterprise stack. It's my pleasure to introduce our 2 fantastic speakers. First is Korinne Alpers, who is Offering Manager with IBM DevOps. And our second presenter is Suman Gopinath, who's an architect with IBM Z Systems. And so I think we're ready to get started. I'm going to hand things over to Korinne. Korinne, it's all yours.
Thank you. Yeah, hi everyone. My name is Korinne. I'm an offering manager for our testing portfolio. And today I'm joined by my colleague Suman, who is our overall testing architect and SDSM. Today we're going to be talking about shift left testing and defining what that means. So testing earlier on in the software delivery lifecycle. And we'll be looking across what we're doing in the distributed world and how we can make sure we have a common pipeline from Z to distributed, that things are the same. I'll pass it on over to Suman for the next slide.
Good morning, good afternoon, good evening, everyone. I'm Suman, and today, as Korinne said, we're talking about shift left testing and across the whole enterprise. Now, as you all know, an enterprise application now is not just a distributed application or just a Z application, and we cannot be in a situation where we say a business functionality is stopped by some things that's not automated or having enough quality in any one part of this enterprise application. It has to embrace the whole enterprise, right? And the key to making sure that you deliver business functionalities on time, the right functionality at the right time, is to have the correct automation in place, a common CI/CD pipeline in place. And if you look at the pipeline that's shown, what you would notice is this is really technology agnostic. So it really shouldn't matter whether you're developing or your application is on the Z or on any of the distributed or cloud platforms now, because the idea is that you should be able to go through this entire pipeline in an automated fashion if you do want to deliver seamlessly. So you have your code, build, provision, deploy, test, and all of this in iterations. And then as and when you deliver a functionality, you go into release, monitor, planning, and the whole cycle starts all over again. So for today's topic, we are talking about being able to integrate continuously and how shift left testing is an important part of it, right? So what would a continuous integration refer to? It is really the ability to deliver code, be able to continuously build and test it, again, seamlessly. And our topic for today is how this is no different for a Z application, right? Just because the Z applications have been around for a long time, it doesn't mean that it cannot be part of a continuous integration cycle. Now, what exactly would you need if you need this in place? So you would need to be able to first of all, you would need to be able to make your code changes in isolation. So you need to be able to have an SCM, which enables you to say, okay, I'm developing feature 1. I need to have my own isolated space where I can develop this feature. You need to be able to make the code change in isolation. You need to be able to test and build your code change, right? And you need to be able to automatically build, having a build automation in place, having the automation that allows you to not only build code, but unit test code, look at your coverage to see if you tested the right parts of the code. And then you need to have a delivery mechanism that delivers your code into the test environments and runs automated testing. So all of this becomes a part of your continuous integration cycle, that is making the code change, having automated build, test processes. And what might be the inhibitors today? One of the foremost things is that the testing that we typically do is very skewed. So most of the testing is centered around testing at integration level, where everything is connected, and then you end up finding issues that could have been caught much earlier in the cycle, say unit testing. So a delayed testing feedback is a primary concern that kind of blocks this whole continuous integration cycle, or the quality in this continuous integration cycle. The other inhibitors include, all these unnecessary wait time. So for example, I'm making a code change, and this code change depends on 3 other teams. Now, to test my change, I typically have to wait for these teams to deliver the change. So I have these unnecessary wait times because I'm dependent on their code. I have unnecessary wait times because I am able to test this code only in an environment, and that environment is either used by somebody else or is not ready for testing. I might also need to even share data and make sure that, okay, the customer data that I work with, ensure that nobody else is changing it, because otherwise I'm not able to test my functionality. So there are so many things that you have to take care of before you get into this entire continuous integration cycle. And in today's session, we are going to talk about how testing as a process, or how being able to test at different stages is so important in this cycle, and how you can automate your tests. And that's what we're going to take you through today. Over to you, Korinne.
All right, so we've been talking about continuous integration, and boiled down in its essence is the ability to make a change in your own environment and be able to run a build, and within that, be able to run automated tests so that when you go and check your code into the CI/CD pipeline, if certain quality checks aren't met, the build will be abandoned. So here we have the test pyramid. This is not something that we created. This is a well-established visualization. The main point from here that you can take is that you should have lots of tests with different granularity. And the more high level your tests are, the less that you should have. So what you want is this great bulk of unit tests, because they are small, they are cheap, they are owned by the developer. And as you go more high level, you have service and like integration, transaction level tests, you have all these different kinds of tests, and then you have your end-to-end UI acceptance testing, and those are more high level, so you'll have fewer of them, and they're going to run more slowly. And the whole point of this is that you have a comprehensive, fast, and maintainable testing suite. All right, so to define unit testing, or how we see unit testing in the Z space especially, is a way of testing the smallest piece of code that we can practically or logically isolate from the rest. So for a ZOS application, we've defined that at the program level. So we're taking a program and we are stubbing out all external calls and interfaces. We want to be able to look at the program and test that one single thing without needing to worry about having a CICS region up and making sure that is my change breaking, or is it the call coming from that CICS? Is it something else? Okay. So we've been talking about unit testing being important for developers, mainly that it's a lot easier when you can find out that your specific change broke the code rather than way further down the line, or even in production, when you find an issue and needing to piece everything apart and figure out where did the issue go wrong. You of course could use a debugger in terms of, okay, this is what happened, but unit testing is repeatable, it's structured, it encourages you to have documented tests and understand how your code works rather than just figuring out what went wrong afterwards. But why is unit testing important for businesses? You'll see some facts and figures to the right that explain continuous integration, which encapsulates unit testing. So unit testing as part of that whole build cycle as being one of the most important, it's ranked as the top in the 2018 GitLab developer report, top ways to mitigate the impacts of development delays. So you'll also see to the right that most developers rate testing as the stage where most delays occur, that the development is not where things end. You get further on, and being able to respond to market means being able to have automated tests in place. So this is why it's important for businesses, and also just the idea, we talk to a lot of customers that say, okay, I'd like to embrace DevOps, but what you're telling me is I'm now going to be more agile, more lean, I'm going to develop more continuously. What that means is, how am I going to test? Where are the tools that I'm going to be able to test this increase in development? Or my test load is going to triple in size. So what we're going to talk about today is what tools are available for mainframe shops. We have a lot of tools in the distributed world, especially Java, you have something like JUnit. But in the Z world, there's not as many options that let a developer really own the unit testing space and understand within their own environment what kind of calls they need to stub out and how to maintain that within their build and CI/CD process. So first, we're going to talk about unit tests. So we work on a tool called zUnit, and we'll be showing a demo of that today. First, I'll describe the core tenets of unit testing. I've touched on this a little bit. Mainly, it's developer-led. It's owned by the developer. They make the code change, and they make the unit test for their actual code change. They manage and store their test cases as well. It is isolated, as I mentioned. It is all external calls and interfaces are stubbed out. Low level, so it's the OS program, and they are fast. They run really quickly. They're very cheap. That is a very important part of unit testing.
Yeah.
Okay.
And the isolation, right? And like Korinne mentioned, the fact that you're able to run just the code that you changed and not bother about where it's running in, that is really important when it comes to unit testing.
Yeah, so what is zUnit? This is a really high level view, so 50,000 foot view. zUnit is an automated unit testing tool that is delivered in a tool called IBM Developer for ZOS, most commonly called IDZ. The tool is all within that IDZ workstation, meaning it is Eclipse driven. So you have a UI, you can easily select the program that you want to test, generate a test case for it, and what it'll show you is your data is parsed out and mapped out to, this is my input, and then I can go and manually put in my output. Or, and this is something we're very proud of, you can go ahead and record a transaction for that program and collect that data. So we have this recording capability that records the entire, all the calls from that program, that transaction that you're running. It collects that data and it imports it into that spreadsheet and shows you this is the data that you've now recorded. You can go ahead and modify it further. You can change it to make a negative test case. You can duplicate it, whatever you need to do. Or you can go ahead and build and run your test case. And what this does is you have this playback file that contains all those calls, and you are able to run your tests as a batch job with no need for CICS or Db2 up. It is all completely done as a batch job. So the current support is for CICS Db2 for COBOL programs. We have, so that means exec CICS and exec SQL calls. And most importantly, as we're talking in this session, with zUnit, ZOS developers can make unit testing part of their daily practice. And these tests can be incorporated in their modern CI/CD pipeline. And Suman will be showing that as well. Okay. Okay, so as I mentioned, everything that zUnit currently supports. Can everyone hear me okay? Suman, can you hear me okay?
You're good?
Okay, I got a notification that it was getting slow network. Okay, so everything zUnit currently supports is, as I mentioned, CICS Db2 and execute under CICS and batch. As we know, customers, you all have very complex applications that use more than this. Luckily, we are part of a continuous delivery train, which means that we deliver as soon as we are done developing. So we have very exciting work that will be coming out very soon. And if you'd like to know more about our roadmap, you can join the sponsor user program, and there's more information at the end of this to talk about that. But right now we have support for CICS and Db2 and some batch. And mainly it's that recording and playback capability so that you can stub out all CICS Db2 calls. On this slide, you'll see just kind of an overview for people who are interested in zUnit and IDZ. We first introduced zUnit and RDZ v8.5, but we started heavily investing in our unit testing and testing strategy and story so December 2018, we released a tech preview of our CICS COBOL support. And this past December, so December 2019, on December 6th, we released a major release for 14.2.1, which debuted a new architecture with a dynamic runtime that we've been working on that enables you to have that recording and playback to run your unit tests as a batch job. So this is just to show if you are on a level of IDZ 9.5, you do need to update all the way to 14.2.1, and there's even a fix that's 14.2.1.1 to get the latest and greatest zUnit capabilities that you can get for your CICS Db2 applications. Okay, and then Suman can take it from here.
Okay, so what would be the process, right? Like you have applications that have existed for a long time, or you might be creating new applications in COBOL or PL1, but what would be the process if for creating the unit test case, or zUnit? So let's assume that a developer gets a requirement. Now, this sample is based on Git as the SCM, and the reason we prefer modern SCMs, it's so easy to do your own code changes in isolation. So the developer, we're just calling her Deb, gets a requirement to modify the code. The developer clones the code application from Git and then tries to go ahead and analyze the program and make the code change. And after the code change is made, she goes and checks if there is a test case, right? So that is probably a new thing because it is not very common to have stored unit test cases for programs today. You might have, but it's not really a very common practice. So if Dave looks and finds out, okay, there's no existing test case, now I have to go ahead and create one. So she can then invoke the zUnit test case editor and fill in the details as required for the test case. What's my input? What should be my expected output? And so on. Now we make it easier by allowing her to import data from a recording. So if you have a program with hundreds of CICS statements, you do not have to bother to know what goes in and out of every structure because you can actually import data from a recording. And once you then create more test data, maybe based on the business functionality you're changing, you could then generate your test case program. So this is an important thing to note because the test case is now a program. And if it's a program, you can check it into an SCM and you can maintain it like you would maintain another COBOL program. And you can then build it and then run it with test coverage, look at the results, see if your test cases pass or fail, and then either modify the test case or go back and modify the program if that's what you need. Maybe you might even need to debug, and you can go ahead and debug this program running under the test case. And if everything is well, you can check in both the program as well as a test case and the config files into the SCM. And this is kind of what we would like to show you today as part of today's demo. So if Korinne, you can just hand over control to me. You go back. Yep. And I will hope the demo gods are in favor today.
Go ahead and share your screen.
Okay. Alrighty. I hope you can see my screen, Korinne. Does it look good?
Looks great.
All right. Okay. So what you're seeing together, for a lot of you, is very familiar. It's IBM Developer for Z Systems. For those of you who are not aware, this is an integrated development environment, Eclipse-based. We've been working and we've had IDZ, erstwhile known as RDZ, and before that WebSphere for many, many years, and it just does wonders. And last year, we again proved how much our customers do need IDZ. So that deviation aside, what you can do with IDZ is you can log into your mainframe, look at your files, your MVS files. If you want to look at DB2, CICS, your PDSs, your source code, submit jobs, all of that, right? Now, what I have here is I have a project, which is my application. And this source code is from Git. So it is possible today to have your source code stored in modern SCMs like Git. You could also use RTC. And it's interesting because this allows you to actually, as a developer or as a team, I can make my code change in my own branch and in isolation and make sure that my code change is perfect before I let others see it, right? So it's very nice, convenient, and truly helps in shift left. So I have my Git project right here, and I have a COBOL program. So I have actually two versions, so I can show you how to create a test case as well as one that I've already created. And if you look at one of my programs here, so this is opened up. It's a COBOL CICS program. So you can see there are exec CICS statements here. And then I also have DB2, right? IDZ is very nice. It can help me quickly understand what the program does. It gives me program flow diagrams and things like that. So after I go ahead and make my change, or maybe even before I make my change, I want to make sure that there are unit test cases for it, right? So typically what I can do is I can either first create the unit test case for the existing program and then go ahead and make the code change, or I can say, let me make the code change and then go ahead. So I could do either. Now I'm going to create a new unit test case. So I go ahead and invoke zUnit, which is from right click and just say create, right? And you have these helpful tooltips, but after that, what it does is it actually parses the program that you're testing. So in this case, it's a COBOL CICS Db2 program. And what you see on the screen is all the input-output structures that go in and out of the program is available with its actual data structure. So if you go to your procedure division, everything that's passed over the COM area is here. And I can even go ahead and say, I want to select one redefined structure, so on, right? And I also have all of the CICS statements, everything in there, and the SQL statements. Now, as a developer, I could say, okay, I want to check if I pass ABCD to the COM area, does it give the result properly, right? So I can go in and fill in details all I want. But you know more than I do that it really doesn't stop here. This is a program, simple program, very large copybook. You could have programs having so many kicks and DB2 statements. So where do you even start entering data, right? And that's where the whole recording helps. So I'm not going to use the blank test case because I'd rather import data. And what I'm going to do is I press on this red record button, and then I say start recording. And at this point, what happens is that I'm pointing to a CICS region where this program runs. And I can now go in and invoke the program. When I say invoke the program, this is actually one of the last programs in a transaction. So typically, you will need to invoke the whole transaction. So you either do it via a green screen, like I'm going to do now, or you could go ahead and do it via web service, or do it via an API or Java screen, however you invoke that transaction. So I'm going to do this traditionally via green screen. I'm going to log into my CICS region. And so before I start, Korinne, can you hear me well and see well?
I can see everything.
Okay, great. Just making sure. So I'm going to go ahead and run my transaction, right? So just querying for a customer. It's in there. I'm going to exit, right? And then I say stop recording. So what happens is it has gone, and the recorder was listening in, and it finds out, yes, there is an entry, and asks me if I want to import the data. So I'm going to import it, and let's say I will call it a new name and say create a test case. So two things happen. One is the test data gets imported into the editor, right? So I can now see, or it's kind of pre-filled for me, much easier for me to rebuild more test cases. So let's say I have to change a business functionality based on a customer number or policy data. So I can easily now, I have a base for creating more tests, right? The second thing that's happened is that the data that's recorded has gone into a playback files that I can use to run my tests. So I can choose to run my tests from the playback file, or I can modify data and provide more data entries in my test case editor, right? So at this moment, if you look at my screen, it's imported the recorded data. So if the customer number 1 comes in through the COM area, this is the expected output that has to be supplied. And that's the test case, because whenever you test something, you provide an input and you have a set of expected output. Now, if you go back, and I want to show you the DB2 statement, right? So this is the data that has come in from DB2. Now, an interesting part, right? How many times have we tried to query data, especially in tables, to find out that, oh, I have to get the city as London, otherwise my test case won't pass. That's what I have to test for. And we have spent so much time either querying a database or querying some other program that belongs to another application to make sure we get the right test data. You do not have to do that anymore, because now you can control what data comes in from that customer table. So I can go in and change anything here. I can say, okay, instead of returning all of this as of Andy as the first name, return Andrew as a first name. So I can do whatever I want with it. And interestingly, what I can also do is I can test for a negative condition. So I have an SQL code of 0. Now I can have a test case. So I can go ahead and say duplicate test case, right? So I have the first test case, recorded data. I'm going to duplicate a test case, and I can say, okay, I want to test for an SQL code of 100. And to make sure everything goes fine. And this should typically fail, or this should fail, not typically, because if it's an SQL code of 100, then I should not get a valid return code in my expected. It should give me an invalid return code. So this test case should fail. So this way, I can create a series of positive and negative test cases. And I don't even have to record every time. I can use one recording as a basis and continuously add data to it. Now, I could do X number of tests when I make this program change. And then when I check it back into the SCM, and tomorrow, if another developer wants to make this code change, that developer could add test case 8, 9, 10, right? So this, over years, you could keep building a really strong unit test suite. And you could run this unit test suite every time you run a build to make sure that whatever code change you make does not break anything, and that you're able to find these issues so much early in your development cycle. So once I put in the test data that's required, I can go ahead and say generate, what essentially does is, using the combination of the playback file and the data that we have changed, for example, SQL call 100, it goes in and generates a COBOL program, which is your actual test case, right? So I'm going to generate the test case. Now, so this is an example where I have two test cases. One is a negative, one is a positive. And you can see that I have, this is a test case that got created, right? So as Korinne mentioned earlier, the test case is a COBOL program, and that's what goes into the SCM. So you can build it, and then you can run this, and you will be running a test. Now, what I have done is I have already built this test case, and I have a couple of test cases more. So I'm going to show you another test case that I've already pre-built. Right? And in this test case, what I'm doing is I'm actually going and storing the test cases into a test case folder, because that's like the best practice. You can isolate your test cases into a test case folder. And while that comes up, so I showed you how to create the test case, but this is a test case I already have. And you can see I have about 3, 4, 5 tests. And this is my negative tests. Like I have put in a negative SQL code. So if I want to see SQL CA, you can see that I have a negative SQL code because I want to show you a failed test case, right? So what I'm going to do is I'm going to run this test case. This is a program for which we have the test case, and we're going to run it. And so basically, there is a test case program that gets executed. This test case program executes 4 tests, which means it calls this program 4 times with different sets of input and expecting different outputs. And as we expect, we have 3 test passes and 1 test fail. And you can tell exactly what failed because it tells you what's the line item that failed, what was the expected value, but what came up. Now, a very interesting bit, or what I would love to do is, and to me, this is mandatory, especially if you're maintaining a program, is that you run this test case with code coverage. So what happens is that you are now able to see, one, if you've made any code changes, whether the test case has covered your code change. 2, what does this current unit test have? How much percentage of data does it really test, or how much percentage of this program does it really test? And that is very, very useful information. So for example, I'm going to combine all these reports for 4 test cases and say, let's open it. I see that I have a pass percentage of 52, right? And then I can go in and let's go to, these are the things. So I have a write error message or an exit which hasn't been executed. Now, all these green markers tell me that I have my test has covered those lines. And very interestingly, see, I have been able to test a couple of negative scenarios. I still have 1 remaining, so I can go in and change that. Now, had I made a code change and was this, let's say the code change was to move 98 to the return code. Now, for all you know, my test case could be successful, but a red mark there would tell me that I haven't tested my code change, right? So this is why running code coverage with your unit tests is really, really useful. Now, the thing that we mentioned, right? Whenever I run this test case, it's running in batch. What does it mean? It's not actually calling CICS. It's not actually calling DB2. And let me prove that to you, right? Why do I say that? I'm going to go ahead and debug this test case. Alrighty, yes. Okay. So I'm going in and I'm debugging the test case, right? And you can see that this is a place where I am calling the program that's being tested, right? This is a program that's being tested. This is a part of a large transaction. It's not really, I'm not invoking the transaction. I'm still testing the program, right? I'm calling the program that's being tested. And then this is the SQL statement that's getting executed. Now let me step in through it. I'm debugging it. I'm not in CICS. And voila, what do you see? That it does not go into DB2, but it goes into the stub, which is inside our test case program, which allows me to give whatever value I want into this DB2 statement. Similarly, what happens when there's a CICS statement? It doesn't go into CICS, but it goes into a stub, again, which allows me to control what happens with every CICS statement. So it's really very simple. At this stage, you do not need a live environment anymore to run your tests. All you need is your PDS. That PDS could be a local PDS, and combined with this local PDS and using an SCM like Git, that is truly testing in isolation and testing really early in the cycle. So we have 4 tests, and I'm going to let it go through all the 4 tests without running them. And let's go back. Okay. And what happens if I really want to make sure that I always run unit tests? I could put gating mechanisms. Let's take a quick recap. I wanted to change a program, which is LGICDB, COBOL program. I noticed there were no test cases, so I created some test cases easily. I ran them with code coverage, so I know whether my program works well. And what I could also do is when I build my program, so what I'm going to do is I'm going to run a user build. A user build is a way by which you can actually build the program that you change if you're using Git as the SCM. And what I'd like to show you is, it's a cool thing about having a user build with DBB. It allows you the opportunity to include as many gating mechanisms you need in your entire build cycle. So what I have done is whenever I build this program, what it does, it goes in and checks if I have any test cases. And if I have any test cases for them, then it runs the test cases as part of the build, which is very, very important in terms of quality. So my program might be written very well, my code change might be perfect, and it might compile properly, like your compile and link edit is all fine, but my build can fail because my test cases haven't passed. So a quality check right there. And what I'd like to show you is how this build will now run test cases. And always in a demo, things take much longer than it is supposed to. So you're going to see it in a bit coming up. But that's the whole concept of being able to do your build in isolation, do test cases as part of your build, and that's the whole reason why we need that area, the unit testing area, where you don't really have to put your changes in the live environment, but you're able to test it much before. You do not have to wait for the other teams to be ready. You do not have to wait for the changes to be available or an environment to be available. You're able to do all of this much, much, much earlier. So if you see here, you will notice the build is fine, because if you go into my compile listing, my compilation is perfect, right? There are no error messages, but it failed. Why? Because I have test cases, and as you know, one of my test cases have failed. Well, so that's what we wanted to show you as part of this demo. And Korinne, I'm sorry if I took too much of this of
No,
the time
that was
of the
great.
demo, but yeah. So let's go back and see what else we can do.
Okay, do you want to stop sharing your screen and I'll go ahead and share mine?
Yep, I've just made you a presenter. Yep.
Okay, great. Can everyone see?
Yep.
All right.
All good.
So we talked about this, but Suman, is there anything you want to cover from this slide?
No, it's just that it is important that not just that you create these unit tests, but these unit tests are run as part of your pipeline. And it's very easy to do that. As you've seen, the tests can be in Git, and the tests can run automatically as part of a build. So it can be done, and it is really important that you have it in place.
Okay, so that was unit testing, and then we'll touch a little bit on integration and service testing, though this session was really focused on unit test because it is that larger pillar for the testing pyramid. For integration or service testing, it's really just trying to determine those grouped units together, how they interact, and are they working correctly together. So for a proper example, that could be the working of a payment transaction, something like that. IBM offers a number of tools and other frameworks for integration or service tests. One is Galassa that recently open sourced. The CICS team has been creating this tool Galassa. It's a highly scalable, flexible test runner focused on integration testing. It has deep ZOS integration. There's other testing tools such as IBM Rational Test Workbench, Rational Test Virtualization Server, and Rational Performance Tester. Okay, Suman, back to you. She's going to cover typical Z testing architecture, what makes it trickier to test for, and ways that you can mitigate that.
Yeah, so we saw that when we were doing unit testing, we eliminated the need for you to have your isolated environment because everything is stepped out. But when we talk about integration tests, system tests, where you run your entire bad job or your entire set of transactions, right? Then the environment becomes a really important piece because, like, if you look at the example, you might have different project teams and they will be testing on the same Alper and sharing data and sharing resources. And in fact, I know of an instance where a customer had to reserve an environment like a month in advance to make sure that his team could actually do testing, right? So the availability of the test environment becomes a serious concern when we talk about service integration, system testing, that level of testing. And there are different ways to mitigate it. The most common being able to create your own environment, right? So there will always be a need to have one end-to-end integrated last user acceptance test, but you could easily create your own environments for integration tests. And there are different ways to do that. So you could have you could use a ZVM and have different environments on that, or you could use something called a ZDNT, Z Systems Development and Test. And Korinne, next slide, please. And for those of you who are not familiar, ZDNT is ZOS running on an x86 hardware. So it is simulated, it is a mainframe architecture that's simulated, and the ZOS that runs on your regular systems runs on it. So when you get into the need for an end-to-end system testing, you would need to create environments on the fly so you can actually, speeden up your testing. And a way to do that is spinning up these ED&T environments. You can spin it up on the cloud, you can bring it up, and you can throw it away after every time you run a test. It's very easy to do that. There are REST APIs that enable you to bring it, to create a ZDNT off an image, and then you could just finish your testing, throw it away, or if your test cases fail, you could then trash it away, bring it back up to an earlier image and start testing. So making sure you have environments available, right? Creating environments is very important when you come to that level of testing. So putting it all together, we would need a combination of a bunch of things to make sure that you shift left, right? Very, very important. You would need to make sure that you have tests run as part of your build. Unit tests in plenty so that you catch your defects much earlier. And you would also need to test or automate every single part of your testing, be it your system test, be it your performance test. Make sure you have the right tools and the right tests in place. Anything you want to add on here, Korinne?
Mainly that, this whole topic was shifting left, so testing earlier on in the software delivery lifecycle and across the enterprise stack. So you can see in this graphic that this isn't just Z. This is across your entire enterprise. That really the entire goal for Z shops and for us as well is that our Z pipeline should be no different for our development teams, that it should all be one common CI/CD pipeline.
Yep, true that.
Okay. Okay, so you can join us to talk about a lot of the things that we've been discussing and see demos of new features as they are developed. So you can join our sponsor user program by contacting me. And in that program, we can discuss a lot of these questions that you're asking. Do you have this or that? The answer could be yes, or it could be no, but here's when you can expect it.
Yeah.
On this slide, here are some resources where you can learn more, such as some documentation, upcoming events such as Share Fort Worth, where Suman will be attending and giving a unit testing presentation as well, and Think 2020, which is our annual IBM conference. Now I think it would be best to go ahead and answer some questions. Let me go ahead and see. Is there anything else that you'd like to say, Suman?
No, we're good. And I think these charts, the presentation, will that be available to Mitch for them to
Yes,
see?
we'll be sending out a link after the webinar with recording link as well
Okay.
as the slides. So you bet.
Okay.
That answers
And we
a
have
few
more.
of the first questions.
All righty. Yes,
And,
we got our first question done. I have to say I'm impressed with your demo. Whatever you did to
oh,
keep the gremlins away. Great job.
thank you. The
All
demo
righty.
gods were very nice.
They were. I'm gonna have to learn some tricks from you. So, so first we've got a lot of great questions from our audience too. So I'm excited to get to these. First question is: so if my company has IDZ, we also have the zUnit capability. So is that included?
Yes, it is. It is delivered in IDZ free of charge. You own it, and you'll just need to upgrade to the latest IDZ version, which would be 14.2.1, and you'll most likely also want the 14.2.1.1 that has some fixes in it as well.
Okay, very good. Question came in about the code coverage when you run the code coverage. Is that something that you see after you've run the test cases, or does it get updated automatically, interactively as you're modifying code?
So code coverage is something that's captured in runtime when your code is being tested. So when I run the test cases, it actually runs my code, and the code coverage picks up what part of the code got tested and what did not. So it is as part of runtime. And a good place to start putting code coverage would be to when you run your unit tests. The other place that is very useful to put code coverage in is as part of your pipeline. When you run any test, you start turn on the code coverage, run the tests just to make sure how much you've covered. And you can even put in like gating mechanisms and say, oh, you know what, my last was this much percentage of coverage. If I don't have so much, I can, fail my pipeline and so on.
Okay, very good, very good. Next question is zUnit for DB2 talks to DB2 subsystem or mock data in Excel?
I think there's two questions here. Are we doing batch DB2? Which is no, we have support for CICS Db2. Batch DB2 is on our roadmap. If you want an exact date, please come contact me and we can get you signed up for the sponsor user. We know that it's a need and we are actively working on it. The other question is, I believe, are you mocking? In execution, no, we are not calling to DB2. We are taking the calls that you recorded in a playback file and feeding them. So you're taking the exact same calls. There's no relinking, no rebinding, there's no changes to your original program. But it's basically as if you are calling DB2, but it's completely batch.
Yeah, and you can add in data. So it is data that is stubbed. So when that exec SQL hits, like you saw, it did not go into DB2, but went into the test case program. So you could choose to add in whatever or write whatever you want. You do not have to wait for, or you do not have to make sure this data is in the DB2 table. It doesn't call DB2 during the run. Yeah.
Okay, excellent. There's also kind of a related question, and that is, can you test against multiple data sets, different versions of data that might be simulated to what's in DB2 database?
So the way you give data today in DB2 is by one, you could take it off the recording, and the other is that you could go in and say, when you select something, select and type in the data that's there. Now, if I wanted to select another row, I could go in and mark and type in those values. So that's the way that you enter data that needs to be handled by the SQL statement. Now, if it's a cursor, you could put in data for the cursor, which is more than one row. So it's something that you do on that test entry editor, and that's how you enter the data.
Mm-hmm. Okay, great. This may go back to the question you were answering earlier, maybe you partially answered this. zUnit support is only for COBOL Db2 CICS and not for standalone COBOL Db2 batch. Is that what you were referring to earlier, Korinne? Or is that a different question?
That's correct. We do not have batch support for Db2. So Db2 calls executed under batch right now, today. But I can say that it is coming, and I can give you dates if you come talk to me.
Okay,
and
great.
You could still test a COBOL batch DB2 program if you, let's say, it queries DB2 and writes to files, you could still test that the files are fine. You just will not be able to stub like we can stub in CICS yet.
That's a good point. When we say it doesn't support it, we mean more the recording and playback. So the idea of being able to completely stub out is not supported, but you can still test the programs. They'll just actually be calling.
Yep.
Okay, great. Just as an aside, Korinne, would you mind putting back up that slide because you're still sharing your desktop, just the contact information?
Oh.
That would be great. So next question is zUnits, is it enabled for PLI?
zUnit supports PL1 batch.
PL1, excuse me, I didn't notice that. Yeah.
PLI, well, that doesn't matter. And we are, like Korinne said, talk to us to know when other support's coming up. Okay.
Is there a module that would work with Hogan systems since their storage and components are proprietary?
It's an interesting concept though, and we would love to work with you on that because that is essentially a call, and we have mechanisms to stub out calls. So we will be very interested to work with you on that.
We've got requests for Hogan support. It's something that's on our radar.
Yep.
So please reach out to us, and we can get your ranked priorities.
Yep.
Okay, perfect. Can I run zUnits through CLI like DBB?
So when I ran the build from DBB and showed that, I guess you can't see my screen, and showed the build and the zUnit part of the build and the build failing, I'm actually running zUnit as part of the DBB user build. So yes, the answer is yes. I can write scripts that would execute zUnit.
Okay, great. Now for the now for the philosophy part of our program. Next question: who's responsible for unit testing, the developer or the tester? I don't know if this is the answer to this question, but what's your opinion about this?
I think we touched on that a little bit in the beginning. In case anyone missed it, we have the opinion that it is owned by developers, that you own your code and you are in charge of, when you make a code change, you know what you've changed and you go ahead and create a test case for it. Now, there are many shops, obviously, that could have testers who also develop, and they might be particularly skilled, but in developing unit tests, but this is delivered within a developer IDE, so we kind of look at it as a developer's tool.
And what I would like to add on is there is also this paradigm shift, right? Everybody is a developer in some way. Even, let's say, you do have a separate testing team, and who is responsible for, as we said in our opinion, more system testing and integration testing. The ideal way is to still automate that those tests. So you are still developing automation, and you should not be manually going in and testing. So in that sense, there is a whole paradigm shift of these traditional testing where you just go into a screen and keep clicking on stuff, and that's something that we will have to get away from, you know.
Well,
Well, I would
that's a
think
good point.
most developers would be happy to get away from manual testing, right?
Yes, yes. I mean, the unit test has to stay with the developer. It's a part of, there is no two. It's an integral part of that build, like code and unit test
Yeah.
before you deliver your code. Yeah.
I'm sorry, Korinne, I interrupted. Were you going to add to that too?
No, I was saying that was a good point, that you see this paradigm shift within how we talk about DevOps and what we consider automation, that everything is becoming code to a certain point, whether it's infrastructure as code or your automated tests. There is a need to be able to go do it, to own it.
Yep.
Okay. Well, maybe next question, we can do a little live debugging, I think, here. Sometimes while we build project in the IDE, there's no error. Build this failed. Why does this happen? Is there a universal answer to this question?
Yeah.
I don't know if that's one we can answer.
That's what a debugging tool is a really helpful thing.
Exactly. You can always change some data, try some different scenarios. So I know this was looking at the next question. I know this is looking at CICS and DB2. Are there
If a build failed, it could be.
I'm sorry, go ahead.
Oh, I think I lost sound for a little bit. Mainly, I don't really have an answer. It could just be that it didn't pass some quality checks at your shop set up.
Okay, great.
Yeah.
Let's go on to our next question. I know this was looking at CICS and DB2. Is there comparable for MQ and IMS, and for languages, say PL1 or HLASM?
Yep.
All of those things are not supported
today.
But
today
it's something that we obviously know needs to get done. Today is very key. So if you reach out to me, I can give you dates on when to expect that. As I mentioned, we really started investing in this tool, like heavily investing in getting more support and getting more development resources last December. So we're coming out with releases as soon as we can, and those are things that are on our roadmap.
Okay, good. We have a few more minutes for questions. Is there a plan to release zUnit as an independent offering, similar to IBM's, sorry, I'm not reading it correctly here, similar to IBM DBB, so that it can be integrated with IDEs like Visual Studio? Any plans to do that?
Talk to us. Talk to us.
Talk to us. That's a really, yeah.
Give us your feedback.
We really would like to finish the tool first for all the support that it needs. But definitely reach out to us if that's something that you are interested in. It's always good to have priorities given to us by customers so we know where to go next. Yep.
Great, absolutely. So last question we'll cover here is, in which languages can you write scripts for IDZ, test scripts?
I'm a little, this is again a question that I'm not sure what exactly the question is, but if you are talking about the languages supported by IDZ as such, it's a whole bunch. IDZ is a really, really comprehensive product that allows you to code in Java, and all of the languages you can write your scripts or whatever in whatever language. But if you're asking your question very specific to zUnit, zUnit generates the test cases in COBOL or COBOL programs and PL1 for PL1 programs, invoking these test cases. You can do that as part of your automation script. So I use the help of DBB APIs, and I wrote Groovy to invoke these test cases. The test cases by itself are in COBOL, but they were invoked using Groovy scripts.
Wonderful. Yeah. Well, that's going to have to complete our question and answer time. Thank you, Korinne and Suman, very much for the fantastic answers, and of course our questions too. Let's jump to announcing our 3 gift card winners. Our 3 winners of the $50 gift cards are Don McGillivray, Samantha Flaherty, and Trisha Brown. So congratulations to all three of you. Yay. So, we'll be in contact with you by getting a hold of those.
Awesome.
So just a reminder, we do have a recording of this webinar and we'll have the slides available. Everyone will be getting an email with a link to those. And be sure to check out DevOps.com for any additional and upcoming exciting webinars with IBM and other folks. It's been my great pleasure. Really appreciate doing the webinar with both of you. Korinne Alpers, who's offering manager with IBM Z DevOps, and Suman Gopinath, who is architect with IBM Z DevOps. I love that name. I just like saying DevOps. How cool is that? So we'd like to thank our audience for joining us today. We appreciate your time is very valuable, and the fact that you spent it with us we're honored to spend it with you. It's been my pleasure hosting today's today's webinar. Everyone have a great day and be careful out there.
Okay.
Thank you so much,
Thanks,
Smith. Thank you,
everyone.
everybody.
Bye.
Bye-bye.